And welcome back again to our tutorials. Today we will speak about escrow service. So what's the escrow definition? It's a framework for a buyer to be sure that he will not release funds to another party, which is the seller, unless he will be totally satisfied with the service provided. Here we consider the problem of buying physical goods with cryptocurrencies. Should be the buyer trust the seller and pay before receiving the goods? Or should the seller trust the buyer and ship the goods before receiving payment? This issue can be solved by using a third-party escrow service. Let's suppose here that we have Alice is selling an item to Bob. The questions that can be asked is, when should Bob pay? If Bob pays immediately, he runs the risk of Alice defrauding him and never sending him the item actually. What if he demands to receive the item before paying? Alice here will run the risk of being defrauded by never being paid. And as we see in our escrow architecture, we must rely on an explicit escrow service if the buyer and seller don't actually trust each other. So instead of sending money to Alice directly, Bob sends the payment to a special escrow address that neither Bob nor Alice is able to withdraw from. Here we will use the multi-signature feature in this schema. So the money is not sent directly to the escrow service address, but instead it's sent to a 2 of 3 multi-signature address with one key controlled by each of the transacting parties and one controlled by the mediator. When there is no dispute, the two transacting parties can together create the transfer transaction. And only when there is a dispute, the mediator gets involved, collaborating with either the buyer or seller to redeem the funds. And here we can see the pseudocode that first we need to create account, new account. This new account will set the script so that either buyer and seller sign, so the deal is done, or buyer and escrow sign, get the money back, or seller and escrow sign for the payment. And third one, buyer deposits, of course, the funds. So our steps to write this code, we need first to set the testnet node on Waves. We need to create 3 accounts basically for buyer, seller, and escrow. We need to generate random account to handle 2 of 3 multi-signature. Then we need to transfer some waves from buyer to the new generated account. This account set the script, compile it, and send the waves to seller if the conditions are met here with the requirement of 2 of 3 multi-signature. So buyer and seller or escrow, and buyer or escrow and seller should sign this transfer transaction. Let's move now to the coding part, and we will use Waves Java library. Okay, so now we need to generate the 3 accounts for buyer and seller and escrow. So okay, we can start. For the buyer, we can get the private key account here from a private key because we need this address to have Waves balance. And also for seller from seed. And nonce 0 and the account from testnet. Also for the escrow. Great, now we need to generate the random account as we discussed. So let's call it new account. We can generate from seed. And here we put the new account seed 0 and from testnet. This random account is to handle the 2 of 3 multi-signature. Also we need to get the address. And now we need to send some waves to this account by using make transfer transaction method. So buyer will send to the new account address. This is equals to 1 waves, and of course the fee. And we can put some attachment like, okay, sending waves, and we need to send this transaction to the node. Here we just need to put some to make it like sleep for 10 seconds for the transaction to be sure the transaction is in the blockchain. So we can just put the try catch here for thread.sleep for like 10 seconds. And catch the interrupted. Now what we need to do is to set the script, yes, that you wrote on our IDE. So here I have it already, so I just can take it and the bytecode of this script. Compile. Here we compile the script, we pass it, and then we just need to copy this bytecode. So now we need the new account to make the script transaction and send it to the network. Okay. Okay, script transaction. Make script. Who will make the script is the new account with the bytecode. And the account, of course, on testnet. And the fees. And then we send this to the node, of course. Now we need also to put like 10 seconds to make sure that the transaction in the blockchain. Okay, now we need to transfer the main idea now to transfer the waves from this new account to the seller address, which is like the escrow idea. So we make transfer from the new account to the seller address, and what else we need here? The amount, fees, then we need to set to sign this transaction from buyer and escrow. They should sign the deal with their proofs. So let's say buyer sig will sign this transaction, and also the escrow should sign it. And we need to set the proofs, of course. We have this with proofs, so the buyer is on the index 0, and the escrow is on the index 2. Now we need to just to print the transaction ID. So let's put like transaction ID and send it to the node and print it. And let's run the code and see the results, guys. So okay, we can like explain again. We created the node on testnet 2. We created the 3 accounts here. Then we generate a random account. Okay, we transfer the money to this account. We set the script, compile it, and then we make a script by this generated account. And finally we transfer from this account to the seller with the signature of buyer and escrow and send it to the node. As we see here, now our result, we got the transaction ID. We can go to Waves test node 2 Waves nodes and to check that this transaction was included in here. We can get the transaction ID and check it. So yes guys, we have it here. Thanks a lot for your attention, and see you next time. In our next tutorial I will explain about our new feature in our IDE, which is the console. So see you in the next video.